All right, let's talk about heat. We feel it, right? We complain when it's too hot, we crank it up when it's too cold. But what if I told you that pretty much everything you think you know about what heat is actually wrong? Okay, let's just jump right in with a question. You've got a hot cup of tea, it feels hot to the touch, so it has to contain heat, doesn't it? I mean, that's just common sense. But the answer, believe it or not, is no. It doesn't. So what's going on here? This is the big reveal. Heat isn't a thing. You can't hold a bucket of heat. Heat is a process. It's energy on the move. As you can see, the key phrase here is energy in transit. Heat is what happens when energy is traveling from one place to another. Okay, so if the tea doesn't contain heat, what does it contain? Well, it has something called internal energy. That's basically just all the jiggling and vibrating energy of its molecules. Heat is just the name we give to that internal energy when it's in the act of being transferred, like when it moves from your hot tea into your colder hands. It's a small difference in words, but it's a huge difference in concept. Now, to really get this, we absolutely have to talk about heat's partner in crime, the thing it always gets mixed up with, temperature. They are definitely not the same thing, and figuring out why is going to make everything click. All right, this table lays it all out for us. Look at the definitions. Heat is the total energy being moved around because of a temperature difference. But temperature? That's just a measure of the average energy of the particles in a substance. And check this out. Heat depends on mass, temperature doesn't. Think about it. A tiny cup of boiling water and a giant bathtub full of boiling water can be the exact same temperature, right? But which one has more energy to transfer? The bathtub, by a long shot. That's the difference between average and total. So if you remember one thing from this section, make it this. Heat is about the total energy, and temperature is about the average energy. Simple as that. Okay, we've established that heat is energy in transit. The next obvious question is, how does it get from point A to point B? Well, it turns out it's got three main ways of traveling. First up, we have conduction. This is the easy one. It's heat transfer by direct touch. Imagine a line of dominoes. You push the first one, and the energy gets passed all the way down the line. That's exactly what's happening on a molecular level. When you stick a metal spoon in your tea, the super-energized tea molecules literally bump into the spoon molecules and get them all excited and vibrating. That energy transfer, that's conduction. Method number 2 is convection. This one is all about movement in fluids, so we're talking liquids and gases. The perfect example is a pot of boiling water. The water at the bottom heats up, gets lighter, and floats to the top. As it rises, the cooler water on top sinks down to take its place, gets heated, and then it rises too. You get this constant circulation, this current that physically carries the heat energy all through the pot. That's convection. And last but not least, we have radiation. Now this is the really wild one. Why? Because unlike the other two, it doesn't need any stuff to travel through. No solids, no liquids, no gases. It just travels as electromagnetic waves. Think about the sun. The warmth you feel on your skin traveled across 93 million miles of empty space to get to you. That is pure, powerful radiation. So we've got the what and the how. We know what heat is and how it moves. But what about the how much? How do we actually put a number on it and calculate the amount of energy that's being transferred? Well, for that, we have a fantastic little formula. Here it is, the heat equation. It might look a little intimidating, but I promise it's super straightforward. Q, that's the heat we want to find. And to get it, you just multiply three things together. The mass of the object, m, something called its specific heat capacity, C, which is just a number that's different for every material, and delta T, which is just the change in temperature. It's literally the recipe for figuring out how much energy moved. Now, behind all of this, conduction, convection, radiation, the whole equation, there is one simple, unbreakable law of the universe, and it's this. Heat always flows from a hotter place to a colder place. Always. It never, ever goes the other way on its own. This one simple rule is the engine that drives everything we've been talking about. So, that brings us to a final question, a little brain teaser for you. If heat only flows from hot to cold, then how on earth does a refrigerator work? Think about it. It's taking heat out of a cold box and dumping it into your warmer kitchen, which seems to go against the number one rule. Well, the answer is a clever application of everything we just covered. Something to chew on. Thanks for digging into this with me.